For the next question, we're outside, so we have a little bit of space, we have a little bit of help. And here we go. Question 5 says you can make a wave by shaking the end of a long rope up and down. Can you show us how to do that? So Mark, just hold it. There we go. We got a nice wave going. So question A says, explain how you would shake the end of the rope to make the wavelength shorter. Scott, show us how you'd make the wavelength shorter. All right, beautiful. So in order to make the wavelength shorter, we must shake the rope faster. Perfect. Question B says, state 2 different ways you could shake the rope to increase energy carried by the wave. Well, there's 2 ways of increasing the energy of the wave, and that is to increase the frequency, which means decreasing the wavelength, or increasing the amplitude. So Scott's going to show us the first one. He's going to decrease the frequency by shaking fast. Perfect. Now Mark is going to show us the second one. He's going to increase the amplitude of the wave. And he is doing that by shaking it harder so that the wave is going higher. Thank you very much, boys. All right, I'm going to have you guys cross out question number 6, but for question number 7, it says a wave in the open ocean between Prince Rupert and Haida Gwaii has an amplitude of 15 meters. So I've shown you a diagram here, which means that this is the rest position, and the crest of the wave is 15 meters above the rest position in a large storm. The wavelength is 1,000 meters. So for part A, we don't need that 1,000 meters. All we need to know is the amplitude is 15 meters. They want to know how far the boat is from the crest here. The simple answer would be to think, well, 15 meters. But in fact, it isn't, because at the bottom of the trough to the rest position is 15 meters, and then it's another 15 meters to the crest. So we're actually looking at an answer of 30 meters. Part B says if the wave travels at a speed of 10 kilometers per hour. Let's remember that the wavelength, this wavelength is 1,000 meters. How many kilometers is that?
1.
That is 1 kilometer, which is very important for us to remember, that each wavelength is 1 kilometer. So again, if the question says that the wave travels at 10 kilometers per hour, we want to know how many waves will pass under a boat in 1 hour. Well, each wave takes 1 kilometer. There are 10 of them in 1 hour. How many minutes in an hour?
60.
60 minutes, which means in 60 minutes, there will be 10 waves. So, how often will a wave pass under the boat? That will be every 6 minutes a wave will pass under the boat. Question 9 can be another tricky one if we don't think about doing a diagram. So they tell us that the female singer sings at a higher frequency. Remember that a higher frequency means that the waves are closer together, so it looks like this. Whereas the male sings with a lower frequency and the waves are a little bit more spread out. Using these 2 diagrams, you should be able to answer both parts A and B to those questions.